Okay guys, so this is the worksheet that I gave you to do this week. I wanted to do a couple of them with you. I'm having my daughter help me film so I can show you. So in order for something to be an acid, like I talked about in the PowerPoint that you guys are supposed to have already watched, right? You have to have a hydrogen, and then for something to be a base, it's going to have a hydroxide. Okay, so when we look at problem 1, we see HCl.
Mom, we ran out of toilet paper.
We'll just go collect some leaves because there's none at the stores.
Okay.
Okay, that was just some entertainment for you guys. Go upstairs. Okay, so this first one is HCl. So we see that there is a hydrogen here, so therefore you know it's a base. So basically you're dissociating the acid. Go upstairs, guys. And you're separating the two ions. So this would be a Bronsted-Lowry acid, so you're going to put Ba. Okay, then here you have an H and the OH. They even highlighted it for you. So because this one has the OH, and you're basically then, and see here we actually had the acid and we dissociated it. Here we're making the base. Okay, so we have the OH. They pointed it out to you. So this one's going to be the base. Remember I told you in the PowerPoint that water can go either way, but since they pointed out to you that it is the base that they're using, then that's what you say. Okay, here you have an H, and then you see that it dissociates into the H ion and then the nitrate by itself. So here we have this as a acid. So we put Ba. Okay? So what basically you're seeing here, down here at the bottom, is that every single base has a conjugate acid. So see here it says NH3 is the base. Okay? Shh. And you compare it with NH4. So see how NH4 has one more hydrogen? That's how you know that this one is the base and this one is the acid. Okay, same thing here. So if we labeled this as the base and this as the conjugate acid, and then we could draw a line here. And then here, this should be the acid by default because you're not going to have a base plus a base. You're only going to have a base plus an acid. So by default, this should be the acid, but we're going to double check. Here it has the H, and here it doesn't have the H. So that means that this one is the acid, and this one is the conjugate base. So then we would draw an arrow that these go together. Okay, does that make sense? So what you're going to do here is you see CN, and you look over here and you see what does CN look like on this side. Okay, it has more H, has one more H. So which one of these two is the acid? This one, right? Because it has the H. So this is going to be our Bronsted-Lowry base, and this is its conjugate acid, and they go together. You can draw arrows or you can write it like they did in the example. And then that means that here you have to have the acid, so Bronsted-Lowry acid, and that's true because look here. See how there's one less H? So that means you're right, and this is the conjugate base. Okay, so this is how you do this worksheet. Remember, we have Lab Friday too that I'll be online. I can help you with it. And then let me show you how to do this because I wanted to show you on the actual calculator. Okay, can you see both?
Mm-hmm.
Okay. So what you're going to do is this H3O concentration is telling you how much hydronium, which is your base, your POH, that you have in a solution. And then OH is telling you, I'm sorry, the H3O, hydronium is telling you how much hydrogen you have in the solution, and the OH is telling you how much hydroxide, so that you have concentration in your solution. So remember, a pH scale, like I told you in the PowerPoint, runs from 1 to 14. 1 to 7 are going to be your acids, and 7 to 14 are going to be your bases, okay? So what we're doing basically is mathematically figuring out if this is our pH, how much of the acid concentration do we have in order to have that pH? So that's the point in this, and then I'm going to show you how to figure it out on your calculator. So basically what you're trying to figure out is if this is the pH that I have based on my litmus paper or on my pH meter, how much acid concentration, how much hydronium ion concentration do I have in that pH? So in order to figure that out, I wrote it here for you, and it's on the answer sheet on RenWeb. you're going to hit on your calculator second log negative, okay? And then the pH. So we're going to do second log negative 3.78. And see the parenthesis there? I'm going to have to close that parenthesis to get the right answer, right? Then I'm going to hit enter. And the answer is 1.66, because we're going to round up, times 10 to the negative 4. So 1.66 times 10 to the negative 4. Okay? Now to get the pOH, the pH scale, like I just told you, is up to 14. So that means that if use is at 3.78, the pOH has to be 14 minus 3.78, and that will tell you how much OH you have, right? Because the scale goes up to 14. So we're going to do 14 minus 3.78, and that's going to give us 10.22. Okay, you guys with me how we got that? I have the calculator in scientific notation, but it's times 10 to the first, so all I'm going to do is move it over one, right? Okay, now to get the concentration of OH, I'm going to do the same thing in my calculator again. So I'm going to go second log negative 10.22, close that parenthesis, and it's going to be 6.03 times 10 to the negative 11. Okay, so if this here is just showing you how to get from each one, okay, and telling you the value. So what you're going to do here is you're going to go back the other way. So I'm going to show you how to mathematically do that. Okay, so you're going to hit negative log in your calculator. Hold on, I'm going to save this and make you guys another video because I have low battery and I don't want it to cut off.